math paper from 2014. And 2014 again, math paper constitutes of 4 sections. You must do everything going up to section 3, but in section 4 you choose one question. Either the statistics question or you do the motion in a straight line question, also known as kinematics. So whichever is your choice, feel free to do, but for practice we will do all questions. So let's go ahead and do this. All right. So looking at the first question, it says, question 1. The function f is defined as f of x is equal to 1 minus x squared. And it says show that f is not 1 to 1. So it says that f of x is equal to 1 minus x squared. This is your function, 1 minus x squared. All right. To show that it is not 1 to 1, a function is not 1 to 1 if more than one element in the domain map to the same element in the codomain. So let's show, there are many ways you can show that this is not 1 to 1. All right, for example, you could just use an example to show them that 2 values is being mapped to the same thing. But generally, this is what people do. To show that it is not 1 to 1, we show that f of a is not equal to f of b. All right, and so what we do is we're gonna show that f of a is not equal to f of b. So solving f of a equal to f of b, all right, what we're gonna see is f of a is equal to 1 minus a squared, and f of b is 1 minus b squared. All right. So from these two, what we're gonna get is we bring over a squared, bring over the 1. So what we get is a squared minus b squared is equal to 0. And if a squared minus b squared is equal to 0, then this is telling us that a is equal to plus or minus b. And so hence, if f is not 1 to 1, that's one way of showing it. So you can say, hence, f is not 1 to 1. Since f of a equal f of b does not imply a equals b. All right, and so that's one reason why it is not 1 to 1. Another reason why I could show that it is not 1 to 1 is you could draw the sketch of it. You could draw a sketch. F of x is 1 minus x squared. 1 minus x squared. So that frowns and it cuts the y-axis at 1. So it looks something like this. Cuts the y-axis at 1. Cuts the x-axis at 1. And negative 1. All right, y and x. And so the other way is you could use a horizontal line test. So the horizontal line test that you use, the horizontal line test, as you can see right here, it detects 2 points. It takes 2 points of intersection. So according to the horizontal line test, f is not 1 to 1. So you can say, according to the horizontal line test, you can say that f is not 1 to 1. It's just one mark, so it don't really matter. It really doesn't. Let's look at the next part of the question now. It says that g of x is a half x minus 3. So it gives us that g of x is a half x minus 3. g of x is equal to a half x minus 3. This is g of x. Now, if g of x is a half x minus 3, what does that mean? It means that to find f g of x, it means to put g of x into f. So f g of x is going to be equal to, we put g of x into f. Putting g of x into f, we put all of this into f. So it's going to become 1 minus a half x minus 3 all squared. Now, of course, we could go ahead and simplify it, but it didn't ask for us to simplify it, so I'm going to leave it right there. And it says state the domain of fg of x, and the domain is, of course, x is an element of real. All right, nice and easy. So that's the second part. So this is part 1. This is part 2a. Now, finally, the next thing it asks for is to find g inverse. To find g inverse, let's do that in red over here. All right, so if we were to interchange x and y, we'd have x is equal to a half. Let's say x is equal to a half g inverse minus 3. Now, all we need to do is make g inverse the subject. So bring over the 3. And so what that means is, what we're getting is x plus 3 divided by 2. And that's g inverse. All right, that's what we get for g inverse. All right, so this is g inverse of x. G inverse of x is equal to x plus 3 divided by 2. Now the next part says sketch the graph of g and g inverse. So let's sketch g and g inverse on the same graph. So to sketch them first, you just draw your axis, your x and your y axis. All right, and let's go back, look at this. So we notice that g of x is a half x minus 3. So it cuts the y-axis at minus 3 and it has a gradient of a half. So it looks something like this. So it looks something like this. This is going to be g of x. All right. And it cuts the y-axis at minus a half. This is going to be g of x. I think this should be minus 3. So this is g of x being a half x minus 3. So the gradient is a half. Nice and easy. And this is where it cuts the x-axis at 6. All right, now next thing it's going to ask us to do is to sketch g inverse. G inverse is x plus 3 over 2. G inverse is x plus 3 over 2. So it cuts the y-axis. Wait, when we multiply through by 2, bring over the 3 and times through by 2. My mistake, oh gosh. There's an error made right here for g inverse. It should be x plus 3 multiplied by 2. So some people might want to write it better and say that g inverse of x is actually 2x plus 6. You may feel free to write it this way as well, that g inverse of x is 2x plus 6. Feel free to write it that way. Nice and easy. Soft. A capital T. Soft. Nice. That's g inverse of x, 2x plus 6. So we can go ahead and sketch that graph, 2x plus 6. Let's do it in a different color. Let's go with something different. 2x plus 6 means it cuts the y-axis at 6 and cuts the x-axis at -3. So gauging it looks something like cuts the y-axis at 6 and the x-axis at 3. Looks something like this. This will be let's try to write this 6 very pretty. This is 6, this is -3, and this is G inverse. So as we can see, this is just a reflection. They're just a reflection of each other in the line y equal x. All right. So you could also state that to them. You could tell them that it's a reflection of each other in the line y equal x. And that's it. Now let's look at part B of the question. Part B. Part B says, when the expression 2x cubed plus a squared minus 5x minus 2 is divided by 2x minus 1, the remainder is -3.5. If the remainder is -3.5, then they're telling us that f of 2x minus 1, so they're telling us that f of a half is equal to -3.5. That's all they're saying. F of a half is -3.5. So what will be f of a half? We're just going to substitute a half into the equation to get, we're going to be getting 2 times a half cube. Substitute a half now, 2 times a half cube plus a times a half square minus 5 times a half minus 2, and that's equal to -3.5. No issues. All we need to do is work this out now. Now 2 times a half cube, 2 times a half cube works out to be a quarter minus 5 times a half minus 2. So this side is working out to be minus 4.25, and then a half square is a half squared is 0.25. So this works out to be plus 0.25a, and that's equal to -3.5. So we can add 4.25 to both sides to get 0.25. A is equal to -3.5 plus 4.25. So we add 4.25 to both sides. Adding them to both sides, what we get is -3.5 plus 4.25, we get 0.75. So what we have is 0.25a is 0.75, and so a must be equal to 3. And that's it, a must be 3. Nice and easy. That takes care of part B. A is 3. Finally, we can look at part C. Let's split this page and work out part C over here. Part C is asking us, it says, the length of a rectangle is y and the width is x. Once they give me something with rectangle and width, I just like to see what I'm doing. I always like to see. I'm very visual. So the length is y and the width is x. Then what else they ask us? They say if the length of the kitchen is a half the square of its width, so they tell us that the length being y, so the length, which is y, they're telling us that y is equal to a half the square of its width. So they're telling us that y is equal to a half the square of its width. So y is a half x squared. Then let's say if the length and its perimeter is 48. So they're telling us that the perimeter of this rectangle, remember perimeter is 2 times the width plus 2 times the length. That's perimeter. Perimeter is the total distance around, and they're telling us that that's equal to 48. Then they're going to ask us to find the dimensions of the kitchen, which is x and y. So if y is equal to a half x squared, if I multiply through by 2, I can say that 2y is equal to x squared. Now, if 2y is x squared, I can substitute for 2y here as x squared. So what I'm getting is x squared plus 2x is equal to 48. X squared plus 2x is equal to 48. Now, if x squared plus 2x is equal to 48, then what can I do? I can bring over 48 to this side to get. This is going to imply x squared plus 2x minus 48, and that's equal to 0. Nice and easy. So all you have to do now is factorize this. So we can factorize this now. So to factorize this, it's going to be x, 8, and 6. And this signs means signs are different, the greater product is positive. Signs are different, the greater one is positive. So this is plus and this is minus. So what does that mean? That means that x is equal to 6 or x is equal to negative 8. But x can't equal negative 8. How x will equal negative 8? X cannot be equal negative 8 because length cannot be negative. So this one is not valid. Not valid. That's because length cannot be negative. So the length cannot be negative, so that one is not valid. All right, so x is 6. Now if x is 6, y is going to be a half 6 squared. And a half 6 squared is going to be a half of 6 squared. 6 squared is 36. And a half of 36. 6 squared 36, a half of 36 is 80. Nice and easy, 80. That's why. So if you want to just give them a statement, when you finish, it's always good to give mathematical statement. You can say the width of kitchen is 6 meters and the length is 80 meters. It's always good to give mathematical statements. So the width of the kitchen is 6 and the length is 8. And that takes care of question 1. Nice and easy. Soft. Question 2. Question 2 says, given that f of x is minus 2x squared minus 12x minus 9, it says, express in vertex form. So let's write down what they give for f of x. They told us that f of x is equal to minus 2x squared minus 12x minus 9. This is f of x. Now clearly from this, we can already see that our a is negative 2. We can see that our b is negative 12. And we can see that our c or C is minus 9. Clearly, C is negative 9. Nice and easy. Now that we know our A, our B, and our C, right, we can actually determine H. Now H is equal to B divided by 2 times A. B in this case is negative 12. Negative 12 is being divided by 2 times A. 2 times negative 2 is negative 4. And negative 12 divided by negative 4 is 3. So that's H. The next we need is K. To determine K. To determine the value of K, it's going to be 4AC minus B squared over 4A. That's to determine the value of K. That's going to be equal to 4 times our A value, which is negative 2, times our C value of negative 9, minus B squared, and what is B? B is negative 12. So it's minus negative 12 squared, and all of this is of course being divided by 4 times A. So it's divided by 4 times 2. And that gives us our value for K. So what does that give us? 4, you put that in your calculator. 4 times negative 2 times negative 9 minus negative 12 being squared. All of that is divided by 4 times 2. And that's positive 9. It should be negative 2, is negative 2, so this is positive 9. I'm getting positive 9 for K. So let's check it again. 4 times negative 2 times negative 9 minus negative 12 squared divided by 4 times negative 2, positive 9. Yes. And so in this case, they want us to write it in the form f of x is equal to K. K in this case is 9 minus, and it says A, so it's 9 minus 2 times x plus 3 all squared. So in this case, we can tell them, K is equal to 9. As you can see, K is 9. A is negative 2. And H is 3. Even though we already worked them out already, just to show them in one statement together. It says state the maximum value of f of x. The maximum value of f of x, is always going to be K. So the max value of f of x is equal to 9. The maximum value of f of x is equal to K, and it's equal to 9. That's the maximum value of f of x. Next thing it asks us for is determine the value of x for which f of x is minimal. So the value of x is equal to minus h. All right, and so x is equal to the value of x for which f of x is maximum is that x value is negative 3. Nice and easy. So this takes care of question 2. So this is part I. Then this is part II. And then we have part III. Nice and easy. The next part of the question says find the set of values for x for which 3 plus 5x minus 2x squared is less than or equal to 0. So this is part B. It says find the set of values for x, for which 3 plus 5x minus 2x squared is less than or equal to 0. Nice. So we can always just factorize this. Should be able to factorize it. And this is less than or equal to 0. To factorize this, as you can see, signs are the same. If we look at it as minus 2x squared plus 5x, minus 2x squared plus 5x plus 3, so let's see, to factorize it, we're going to need a 2x and the x out here. All right, we're going to need a plus and a minus. We're going to need a 3 and a 1. So let's put the 3 here and the 1 here. This time this will give us 6x, and this time this will give us x. We need 6x minus x. So if we put the minus here and put the plus here, this is fine. So this time this gives us the 3, this time this gives us 6x. Yep, so this is fine. So this is what we have. It's always good to sketch a graph to see what we have. So the graph is asking us now, so this is your x-axis. The roots of this equation would be x is 3 and x is, this looks like minus a half. And they want the portion of the graph that is less than or equal to 0. Less than or equal to 0 is down here. So the portion of the graph that's going to be less than or equal to 0 is going to be, so this is the solution. So x is such that x is going to be less than or equal to minus a half, or x is going to be greater than or equal to 3. And that's the solution. Nice and easy. Looking at the graph, that's what we're getting. Nice and easy. Soft. Now part C. Part C says now, a series is given by 0.2 plus 0.02 plus 0.002 plus 0.00002, and it continuing. It says show that the sequence is geometric. So as you can see, the sequence, the series is 0.2 plus 0.02 plus 0.002 plus 0.0002, and it continues. So to show that it is, if it is, so if the series is geometric, then if the series is geometric, then what do we know? Then it has a common ratio. It has a common ratio. If it has a common ratio, we can find that common ratio. The common ratio R is equal to the second term divided by the first term, which is 0.02 over 0.2. And this should also be equal to the third term divided by the second term, which is 0.002 over 0.02. And it should also be equal to the fourth term divided by the third term. It should be equal to 0.0002 over 0.002. All right, so let's work these out then. So we have 0.02 divided by 0.2. I'm getting 0.1 in all cases. So yes, it has a common ratio of 0.1. So indeed, it is geometric. So yes, it is geometric. So we can conclude, yes, it is geometric. Now, since the series is geometric, what do we do next? It says, find the sum to infinity. Find the sum to infinity. Now, sum to infinity is a simple formula that you have to remember. Sum to infinity is equal to a over 1 minus r. Sum to infinity is equal to a over 1 minus r, where a is the first term of the series. The first term is 0.2. So 0.2 divided by 1 minus r, 1 minus 0.1. So we have 0.2. This is 0.1, not 1 minus 1. 0.2 over 1 minus 0.1 is 0.2 over 0.9. 0.2 being divided by 0.9, that's just 2 over 9. This works out to just be 2 over 9. And so that's the sum to infinity. 0.2 divided by 0.9, that's 2 over 9. Nice and easy, soft. And that takes care of question 2. Easy and cheesy and cheesy. Too easy, man. Too easy. You have to tell them, man. Too easy. Too easy. Tell them, man. Nice and easy question. Question 3. Question 3 is section 2. It usually constitutes of vectors, trigonometry, and coordinate geometry. So question 3 says, determine the value of k such that x plus 3y equals 6 and kx plus 2y equals 12 are perpendicular to each other. So the lines are what? The lines are perpendicular to each other. Now, if the lines are perpendicular to each other, that means the product of their gradients is -1. All right, so let's write that down. So if the two lines are perpendicular, then the product of their gradient is -1. So since we know that this is what happens if the two lines are perpendicular, the product of their gradient is -1. So all we pretty much need to do is let's find the gradient for the first line. So the first line tells me that x plus 3y is equal to what? Is equal to 6. So making y the subject will tell us that 3y is equal to minus x plus 6. All I did was subtract x from both sides. Then I'm going to divide both sides by 3. So dividing by 3, I'm going to get that it's minus 1 over 3x plus 6 over 3. And so the gradient of this line, so the gradient m for this line is -1 over 3. All right. Now the next line that they give is kx plus 2y equal 12. So they give us now kx plus 2y. Kx plus 2y is equal to 12. Now that you have kx plus 2y is equal to 12, what does that mean? That means that if we make 2y the subject, we're going to get that 2y is equal to minus kx. 2y is equal to minus kx plus 12. And so all you need to do now is divide both sides by 2. Dividing both sides by 2. And what does that tell us? That tells us that this is m1 and this will be m2. And so the gradient is minus k over 2. Alright? Minus k over 2. But since the two lines are perpendicular, what we know is that the product of their gradient is negative 1. So that means that minus 1 over 3 multiplied by minus k over 2 is equal to negative 1. That's what perpendicular lines mean. The product of their gradient is negative 1. So minus 1 times minus k is k. 3 times 2 is 6. So k over 6 is equal to negative 1. And if k over 6 is negative 1, then k must be negative 6. So k is equal to negative 6. So that's the answer, k equal negative 6. So we can tell them that right here. Hence, k is equal to negative 6. Next it says a circle of radius 5 centimeter has its center to be the point of intersection of the two perpendicular lines. Determine the equation of this circle. So we have these two lines, all right? We have these two lines and they intersect at the center. So let me draw a circle. I always like a schematic. This is the line, all right? K is negative 6. And so when you think about it, then really and truly, when we think about it, really and truly what we have is this is 6 over 2 is 3. And so we have the line 3x plus 6. So that has a positive gradient. So let me draw a line with a positive gradient passing through the center. And the other line is going to be the x plus 3y equals 6. That have a gradient of minus 1 over 3. That will look something like this. And both of them intersect at the center. Both of them intersect at the center. So what we need to do is find that point of intersection to get. We need to find that point of intersection, and then that gives us the center of the circle. All right, so let's go ahead and find the center. Finding the center, that means we solve these two equations simultaneously. So there are many ways to solve them simultaneously. I realize that we have x plus 3y equal to 6. And the next equation we have is k is minus 6x plus 2y, and that's equal to 12. Now I love elimination method, and so what I am going to do is I'm going to multiply the first equation by 6. I'm going to multiply this first equation by 6, and that is going to give me, and I multiply it by 6, that is giving me 6x plus 6 times 3 is 18y, and that's equal to 6 times 6 is 36. I love to multiply it like that, oh gosh. Oh no, how does it dissipate? Alright, so it dissipates. So let's do it again. Multiply the first equation by 6 to get 6x plus 6 times 3 is 18y. That's equal to 36. The second equation, which is minus 6x plus 2y, that's equal to 12. Now if we add these two equations, if we add them, by adding them, what we get is minus 6x plus minus 6x plus minus 6x gone. Then 18y plus 2y, that becomes 20y. And 20y is equal to 36. 36 is equal to 36 plus 12 is 48. And we divide through by that. And so what we're getting is 48 over 20. That will give us y. And so y is equal to that's 2.4. Y is 2.4, or we would say 12 over 5. 12 over 5. So that is the value for y. Y is 12 over 5. Since y is 12 over 5, we can find x, because x is just equal to 6 minus 3y. So x is 6 minus 3 times y, where y is 2.4, or 12 over 5, and that will give us x. 6 minus 3 times 12 over 5, and so y, x is 6 over minus 6 over 5. That's x minus 6 over 5. And so the radius of the circle, which they said is 5, and so the circle will have equation x plus 6 over 5 square, x plus 6 over 5 square, plus y minus 12 over 5 square, and that's equal to r square. R square is 25. So that's what we have. Nice and easy. That's the equation of the circle. Soft. No issues at all. So nice and easy. Lovely. So let's continue with the next part of the question now. So looking at the next part of the question, it is the vectors part, and it says RST is a triangle in the coordinate plane. Position vectors RS and T relative to origin O is 1, 1, 3, minus 1, and 4, 4. Now, anytime I'm doing these questions, I love to get a schematic of what they are asking. I just love to see it as a schematic, not a rough thing, but just a sketch. So RST, R is the point 1, 1. So let's say this is when X is 1, Y is 1 here. Then this is the point R. This is the point R. And then they want the point S is 3 minus 1. So let's say this is 3. And this is minus 1. So 3 minus 1 is right here. This is S. And then they want the point T, which is 4, 4. So let's say this is 4. And 4 on the Y. Let's go up some more. So 1, 2, 3, 4. 4 is somewhere here. All right. And so this is the point RST. Nice and easy. Then they want us to, they said, show that TRS is 90 degrees. Angle TRS. To show angle TRS is 90 degrees. TRS. So this is the angle. I'm just connecting them as a triangle. It's easier this way. You can see it. So they want us to show, so based on our sketch, they want us to show that TRS is 90 degrees. To show that TRS is 90 degrees, we need to find vector SR and vector TR. Those are what we need to find. And then we can use the formula to find the angle. All right. So what we know is that the cosine of angle TRS, the cosine of angle TRS is equal to TR dot, remember the cosine of any angle is the dot product over their norms. Is the dot product, so it's going to be TR dot RS. Well, not R, it's actually SR, so it's TR dot SR, TR dot SR divided by the norm of TR times the norm of SR. The norm of TR times the norm of SR. So let's work out these now. So before we get back to this formula, let's work out all of them down here. So first and foremost, vector TR is going to be equal to OR minus OT. So vector TR is OR minus OT. That's vector TR. OR is 1, 1. So this works out to be OR, which is 1, 1, minus OT, and OT is 4, 4. So 1, 1 minus 4, 4 is minus 3, minus 3. So this works out to be minus 3, minus 3. That's vector TR. Next we need is vector SR. Vector SR. So when we need vector SR is OR minus OS. Vector SR is OR minus OS. So that's vector SR, OR minus OS. So now vector OR, which we know is 1, 1, minus vector OS. What is vector OS? Vector OS is 3, negative 1. Now 1 minus 3, 1 minus 3 is negative 2. And 1 minus minus 1, minus 1 and minus 1, that become plus, and so that's minus 2, minus 2. So now we need their vector norms. So the norm of vector TR is going to be equal to 3 squared plus 3 squared. That's the norm. 3 squared plus 3 squared, all square rooted. And so the norm of vector TR is going to be equal to 9 plus 9, that's 18. So the norm of TR is the square root of 18. Nice and easy. Now we need the norm of SR. The norm of SR is going to be equal to, not vector SR, the norm or the magnitude. The norm of vector SR is 2 squared plus 2 squared. So that works out to be the square root of 2 squared plus 2 squared. That's 4 plus 4, and that's the square root of 8. So this works out to just be the square root of 8. All right, so that's what we have. So now we can go back and say, okay, the cos of TRS, the cos of angle TRS is going to be equal to the dot product, which is the dot product of minus 3, minus 3, minus 3, minus 3, dot minus 2, 2. We'll show this dot product over the norm of root 18 times the norm of root 8. And so we'll work this out. What we're going to get is minus 3 dot minus 2. That's going to be, as we can see, this works out to just be 0. Look at it. Minus 3 dot minus 2 is positive 8. 8 minus 8 is 0. So since cosine of TRS is equal to 0, then this implies angle TRS is cos inverse of 0. Angle TRS works out to be cos inverse of 0. And so TRS is cos inverse of 0, and cos inverse of 0 is 90 degrees. So this shows that TRS is 90. Now it says determine the length of the hypotenuse. Now as we can see, the hypotenuse will be TS. All right, the hypotenuse will be TS. So we need to find vector TS. Now there are two ways to do it. We don't even need to find vector TS. Since we already found TR and SR, what do we know? We know this. Since it's a right angle triangle, then applying Pythagoras theorem, we know that TS squared, which is the hypotenuse, is going to be equal to RS squared plus RT squared. Nice, so we can find the hypotenuse already. So it's going to work out to be the root 18 squared, which is 18 plus 8, and that is TS squared. This works out to be 26. So that is TS squared. But we need TS. So we're going to square root both sides to get that TS is equal to the square root of 26. So TS is the square root of 26 units. That's the length of vector TS. Now that's the length of TS, the hypotenuse. That's TS. Nice and easy. Soft. Now we're at question 4. Now let's look at question 4. What is question 4? Question 4 says, Figure 1 shows the sector OAB of a circle with center O, radius 9, and an angle of 0.7 radians. It says find the area of sector OAB. So let's find the area of the sector. Now area of a sector, I like to call it AS. Area of a sector is equal to theta over 360 times pi r squared. So it's theta, which is 0.7 over 360, 0.7 over 2 pi times pi r squared. And the radius it says is 9. So this will give us the area of the sector. So we get 0.7 divided by 2 multiplied by 9 squared. That's 28.35 pi. So the area of the sector is 28.35 because the pi will cancel the pi. So the area of the sector is 28.35 centimeters squared. That's the area of the sector. Part 2, it says, hence, find the area of the shaded region. To find the area of the shaded region, the area of the shaded region, I'm going to call it area shaded. Area shaded. Area shaded is equal to the area of the triangle. Area shaded is the area of the triangle minus the area of the sector. Area of triangle minus the area of sector, and that will give us area shaded. All right. Area of triangle minus the area of Area of the triangle minus the area of the sector, that will give us the area shaded. Nice and easy. Now the area of the triangle. To find the area of the triangle now, the area of the triangle is right angle. The triangle is right angle. So first thing I want you to picture is look at this. This is the triangle, all right? We only know one side on the triangle. So in order to find the area of this triangle, we need to know another side, right? We only know one side. But we know that this angle is 90 degrees. We know that this side is 9 centimeters. And we know the angle right here is 0.7. And that's in radians. So we already know this side. What is this side going to be equal to? This side is going to be equal to angles in a triangle sum to 180, which is pi radians. So if it's pi radians, we know that this is pi by 2. So we know that pi by 2 plus this angle of 0.7 plus this unknown angle, let's call it x, plus that unknown angle x, we know that must equal to 180. 180 is pi. So now that we know that all of that add together to give pi, we can find what x is. So x is going to be equal to, bring over the pi by 2, pi minus pi by 2 is just pi by 2, and then bring over the 0.7, and so this angle x is 0.87 radians. This is 0.87 radians. 0.87 radians. Now that this angle is 0.87 radians, we need to find the height, right? Need to find the height. Now look how we're going to find the height. This side corresponds to this, and so this side corresponds to this, which is the height. All right, so what does that mean? We're going to use sine rule to find what is x. We need to know what is x so we can find the area. So 9 over 0.87, 9 over 0.87, and it's not 0.87, it's the sine of 0.87. 9 over the sine of 0.87 is equal to the height, over height over 0.7. So from this we can find the height. This is the sine of 0.7. So from this we can find h, and we can say that h is equal to 9 sine 0.7, 9 sine 0.7 over the sine of 0.87. That will give us the height of the triangle. Now that we get the height of the triangle, so we'll put this in our calculator. All right, so put that in your calculator and you get 9 sine 0.7 divided by the sine of 0.87. 9, my calculator, come on. 9 sine 0.7 divided by the sine of 0.87. I get 7.59. So that's the height, 7.59. Height is 7.59. All right. So what that means, so that area shaded is equal to a half the base of 9 times the height, half base times height, and the height is 7.59 minus the area of the sector, and the area of the sector, which we found already, is 28.35. And so now we'll put all of this in our calculator to get the area shaded. So a half of 9 times 7.59 minus 28.35, and I get 5.81. This works out to be 5.81 centimeters squared. That's the area shaded. Nice and easy. Soft. That's the answer. That's the area shaded. Now let's look at part B. Part B is trigonometry, by the way. And so the trigonometry that they're given, it is telling us that part B, it says, show that the cos of x plus pi by 6 is that weird looking formula. Let's go ahead and do that. So it wants us to evaluate the cos of x plus, what is that? Pi by 6. Now, first thing is to expand the cos of x plus pi by 6, it is cos minus sine. So all we need to know that this is going to be equal to cos x times the cos of pi by 6 minus sine x times the sine of pi by 6. Cos minus sine. So it's cos x times cos pi by 6 minus sine x times the sine of pi by 6. Nice and easy. Soft. Extremely easy. So now that this is what we have, now cos of pi by 6 is the cos of 30, and the cos of 30 is root 3 over 2. So the cos of 30 is root 3 over 2 times the cosine of x, root 3 over 2 times the cosine of x, minus the sine of pi by 6. The sine of pi by 6 is a half. So it works out to be minus a half sine x. Nice and easy. Now, of course, we're going to factor out the half. We're going to factor out the half to have a half in bracket. Don't factor out the half, we're left back with cos x, well, root 3 cos x so we're left back with root 3 cos x minus sine x. And so it is shown very easy, very easy question. Soft. Nice and easy. That's the answer. That's proven. Now we have part C to do now. Let's have a look at part C. Let's have a look at part C. So for part C, it says prove that the identity tan theta sine theta over 1 minus cos theta is 1 plus 1 over cos theta. Let's go ahead and do this. To prove these things, you always start by writing down the left-hand side. So the left-hand side, as we know, it is equivalent to tan theta times the sine of theta, tan theta times the sine of theta divided by 1 minus cos theta. So this is what we have, tan theta sine theta divided by 1 minus cos theta. This is going to be equivalent to tan theta. Tan theta, as we know it, tan theta is sine theta over cos theta. So we can rewrite the tan part as sine theta over cos theta. And of course, this is being multiplied by sine theta. But then all of this is being divided by 1 minus cos theta. Nice and easy. Now the next thing we just have to note is that, well, sine theta over cos theta times sine theta times sine theta is sine square theta. Sine theta times sine theta is sine square theta. So that's sine square theta over cos theta. And that's being divided by 1 minus cos theta. Instead of writing divided by 1 minus cos theta, divided by 1 minus cos theta, I'm going to just put multiplied by 1 minus cos theta. Because dividing is the same as dividing. My apologies here. We're dividing it by 1 minus cos theta, so it's multiplied by 1 over 1 minus cos theta. Now, first and foremost, we need to notice that sine square theta is 1 minus cos square theta. So we can rewrite this as 1 minus cos square theta. So we have 1 minus cos square theta. So it's 1 minus cos square theta over cos theta times 1 over 1 minus cos theta. This is so boring and easy. Now, we can now use difference of two squares to separate 1 minus cos square theta, as we can separate it as 1 minus cos theta, separate it as 1 minus cos theta multiplied by 1 plus cos theta. 1 minus cos theta multiplied by 1 plus cos theta, and all of this is divided by cos theta. Then we multiply it by 1 over 1 minus cos theta. Now 1 minus cos theta right here cancels the 1 minus cos theta here. So what we're left back with is 1 plus cos theta over cos theta. But 1 plus cos theta, this is what we're left back with. 1 plus cos theta over cos theta. Now I don't want to go somewhere else, so I'm just going to bring it to the top. I don't like to do that, but I'll bring it to the top right here. And so this 1 plus cos theta over cos theta, we can separate it as 1 over cos theta plus cos theta over cos theta. But cos theta over cos theta is 1. And so now this is equivalent to our right-hand side. And so we've proven it this way. Nice and easy, soft. So we've done the proof. That's it. Nice and easy. That takes care of question 4. Now we go to question 5. Question 5, which is differentiation. Question 5 says a curve, or the equation of a curve is, question 5 says the equation of a curve is, let's go back to our black ink. It says y is equal to 3 plus 4x minus x squared. So y is equal to 3 plus 4x minus x squared. And it goes next by asking us, the point 36 lies on the curve. Find the equation of the tangent to the curve at P. So to find the equation of the tangent to the curve, first we need to do is find dy by dx. That's the first thing. Let's find dy by dx. Find dy by dx, and dy by dx is equal to, we differentiate 4x to get 4. We differentiate x squared to get minus 2x. So that's dy by dx. So dy by dx is 4 minus 2x. At the point P, and P is the point 36. At the point 36, we can say that the gradient of the tangent is going to be equal to, we plug in 3 in here to get 4 minus 2 times 3. That will give us the gradient of the tangent, which is equal to 4 minus 6, which is negative 2. That's the gradient of the tangent, negative 2. Now that the gradient of the tangent is negative 2, we can find the equation of the tangent. And so the equation of the tangent, is going to be y minus the y value at p, so it's y minus 6, and that's going to be equal to the gradient of the tangent, which is negative 2x into x minus 3. But we can't finish here, so they want it in a particular form. They want it in the form ax plus by. So what we need to do is write it as y minus 6 is equal to negative 2x plus 6. And then we're going to bring the 2x over here to get 2x plus y. And then we subtract 6 from both sides to get 2x plus y minus 12 is equal to 0. Nice and easy. Soft. And that's the answer. That's the equation of the tangent. Nice. Now next it goes to ask us, given that 2x cubed minus 9x squared minus 24 plus 7 is f of x, find all stationary values of f. So we have our f of x, and it says that f of x is 2x cubed minus 9x squared, 2x cubed minus 9x squared minus 24x plus 7. This is f of x. All right. Now, first thing we need to do is we need to find f prime of x. We need to find f prime of x. F prime of x. Now, f prime of x is going to be equal to, bring down the power to get 6x squared minus 2 times 9 is 18x minus 24. That's going to be f prime of x, 6x squared minus 18x minus 24. But at a stationary point, the derivative is equal to 0. So we set the derivative equal to 0. We can then divide through by 6 to get that equation becomes x squared minus 3x minus 4 is equal to 0. So divide through that equation by 6 to get this new equation. We can then factorize it now equal to 0. And that's x, 4 and 1. It says signs are different, but the greater product is negative, minus and plus. And so what we're getting is x is equal to negative 1, or x is equal to 4. Nice and easy. X is equal to negative 1, or x is equal to 4. All right, and so we can find the y value when x is negative 1 by putting in negative 1 up here. So we get 2 times negative 1 cubed minus 9 times negative 1 squared minus 24 times negative 1 plus 7. And we're getting y is 20. And then we can put in y right here. So put in y as 4, put x as 4 here. So we're going to get 2 times 4 cubed minus 9 times 4 squared minus 24 times 4 plus 7, and that's negative 105. Negative 105. And so the 2 points are, we can tell them now that the 2 stationary points are minus 120 and 4 minus 105. Without even looking at it, I can tell their nature. Think about it. This big negative number, wouldn't that be the lowest point? This one is already the minimum. And 20, that's a big Y value. This must be the maximum. Even without doing it, we know that. But let's just do it for working out case. So we're going to say f double prime of x is going to be equal to f double prime of x. We differentiate 6x squared to get 12x minus 18. That's f double prime of x. We get 12x minus 18. Now, since f double prime of x is 12x minus 18, now what we need to find now is f double prime of minus 1. F double prime of minus 1 is going to be equal to 12 times minus 1 minus 18. 12 times minus 1 minus 18 is negative 30. All right. And then now f double prime of, so negative 30, as we can see right here, that is less than 0. And so that's the maximum point. When it is less than 0, this is the maximum point. And so we can conclude that minus 120 is a maximum point. Now, since minus 120 is a maximum point, now we can go further to find f double prime. Find f double prime of 4. F double prime of 4 is going to be equal to 12 times 4. 12 times 4, which is 48. 48 minus 18, which is 30. And 30 is greater than 0. And so we can conclude that 4, so we can conclude 4, negative 105 is a minimum stationary point. Nice and easy. Nice. And that's it. So this is part 1 and this is part 2. Part 1, part 2. And that finish off question 5. Now we can go to question 6, which is integration. Question 6. Question 6 is integration, and it asks us to integrate from 2 to 4 x times x squared minus 2. Easy question. So let's boil up this integration. They want us to integrate x times x squared minus 2. X times x squared minus 2 dx. So if we're integrating this now, what are we doing? And we're integrating from 2 to 4. So integrating from 2 to 4, that's going to be equal to the integral from 2 to 4 of x times x squared is x cubed minus 2x. That's what we have, x cubed minus 2x dx. Now, since this is what we have, all we're going to do is add 1 to the power, then divide by the power. So we have x to the 4 over 4 minus, now 2x squared, we're going to add 1 to the power, divide by that power. And remember, we're integrating from 2 to 4. Since we're integrating from 2 to 4, we just plug in 4 first. When you plug in 4, what you're getting is 4 to the 4th power, which I don't know. 4 to the 4th power is 256 divided by 4. This works out to be, I'm getting 64 minus, we'll put in 4 here. 4 squared is 16, so I get 64 minus 16. Subtract 2 to the 4th power. 2 to the 4th power is 2 to the 4th power. That looks like 2 to the 4 is 16. 16 over 4 is 4. Minus, put in 2 here. 2 squared is 4. And so this works out to be 64 minus 16, which is 48. So that's 48. That's the integral. 48 units. Don't want to say units squared, it's not area, I don't know. Units. That's part A. Part B. Part B is asking us to evaluate the integral of 0 to pi by 3. 0 to pi by 3 of 4 cos x plus 2 sin x. 4 cos x plus 2 sin x. Nice and easy. This is what we have. So this works out to be now the integral of 0 to pi by 3 of 4 cos x plus 2 sin x, that works out to be 4 cos x plus 2 sin x. So when we integrate cos, we get sine. So it works out to be 4 sin x. Then when we integrate sine, we get minus cos. So this works out to be minus 2 cos x. And of course, we're integrating from 0 to pi by 3. So all we need to do now is substitute pi by 3. Nice, so let's plug in pi by 3. Plugging in pi by 3, what we're getting is the sine of pi by 3, or sine 60. Sine 60 is root 3 over 2. So this works out to be 4 times the root of 3 divided by 2. Then put in pi by 3 here. The cos of pi by 3 is a half. This works out to be minus 2 times a half, which is 1. Close up that bracket. Subtract. Sine of 0 is 0. And the cos of 0 is 1. So this works out to be minus 2. So all of this works out to be 4 root 3 over 2 is 2 root 3. 2 root 3 minus 1. This works out to be 2 root 3 minus 1. And then minus 2 becomes plus 2. This works out to be 2 root 3 minus 1 plus 2. And so this works out to be 2 root 3 plus 1. Nice and easy. Soft. Now let's have a look at part C. Part C tells us that the curve passes through the point 2, negative 5, and dy by dx is 6x squared minus 1. It says find the equation of the curve and then find the finite region bounded by the curve and the x-axis and the line x equals 3 and x equals 4. So this is really easy. They tell us dy by dx, they tell us that that's equal to dy by dx, they say that's equal to 6x squared minus 1. So dy by dx is 6x squared minus 1. Now since dy by dx is 6x squared minus 1, then y is going to be equal to the integral of dy by dx. So y is the integral of 6x squared minus 1. That's how we find y. We integrate dy by dx. When we integrate that now, what we're going to get is add 1 to the power 6x cubed, divide by the power of 3 minus x plus some constant c. Plus some constant c. Nice and easy. Now once we do that now, and we have the point 25, we have the point 25, so P is the point 2, negative 5. So what does that mean? That means that when y is negative 5, we have negative 5 is going to be equal to, now 6 over 3 is 2, so it's 2 times 2 cubed, 2 times 2 cubed minus 2 plus c. Alright, and so this is what we have. So let's evaluate c. So evaluating c, what we're going to get is 2 times 2 cubed minus 2, that's 14. So this is 14 plus c. And so if we bring over the 14 over here, it becomes minus 5 minus 14, which is minus 19. So that is c. So hence, we can conclude that y is equal to 2x cubed minus x minus 19. That is y. Nice and easy. Soft. All right, so that's the equation of the curve. All right, nice equation of the curve. Next thing is that it asks us to find the area of the finite region bounded by the lines x equal 3, x being 4, and also the x-axis. So what they're asking us for is to find area of the finite region. The area of the finite region is going to be the integral from x being 3 to 4 of 2x cubed minus x minus 19. And that's going to be equal to 2x cubed minus x minus 19. So to find that area, we add 1 to the power. So we get 2x to the 4 divided by the new power of 4 minus x squared over 2 minus 19x. And we integrate that from 3 to 4. So let's work this out now. So all we have to do is plug in 4 first. So plug in 4, and what we're getting is 4 raised to the 4th power divided by, so we have 2 times 4 raised to the 4th power divided by 4. I get 128 right here. So we're getting 128. Then we plug in 4 here, we get 4 squared is 16. 16 over 2 is 8, so we get minus 8. Minus 19 times 4 is 76. So we get 76. We'll close up that. Minus, this is where it gets tricky because we put in 3. 3 to the 4th power is 81 times 2 is 162 divided by 4. So that looks like 81 over 2. So I get 81 over 2. Then we'll plug in 3 right here. That doesn't look like 2, so let's fix that. 81 over 2. Then we'll plug in 3 right here. 3 squared is 9. So we'll get 9 over 2. And then we'll plug in 3 right here to get minus 3 times 19. That looks like 3 times 19 is 50, 57, 57. So now we can take their differences. So all of this we just put in the calculator. 128 minus 8 minus 76. That's 44. Minus 81 over 2 minus 9 over 2 minus 57, and I'm getting 65. So I'm getting that area is 65 units square. Nice and easy, 65 units square, soft, soft, with a capital T, nice and too easy, soft. Now we go to question 7. Question 7, it says that, this is section 4 by the way, and we know that we are only required to do one, but for practicing sakes, we're doing both. It says there are 60 students in the sixth form of a certain school. Mathematics is studied by 27 of them, biology by 20 of them, and students study neither mathematics nor biology. If a student is selected at random, what is the probability that the student is studying both maths and biology only? Now, I like to do these questions with a Venn diagram. So I just like to set up my Venn diagram. Nice. My Venn diagram looking very pretty. All right. So setting up my Venn diagram. I want it to look pretty. Yes, this look pretty. No, sir, this too pretty, man. Now it says there are 60 students in the school. Only 66 formers. Mathematics is studied by 27 of them, biology by 20 of them, and 22 students do neither biology nor maths. So outside you have 22 pitney that them decide that them not hurt up them head. Biology are too much reading, right? And they don't want to do mathematics. Now let's say this is mathematics M and this is biology B. Let's say X amount of students to both, all right? Let's just put it as X. Now, for those that the maths only will be 27 minus X, all right? And then it says biology only will be 20 minus X. So this is what we have. So let's find out what is X to know what's the intersection. Now we know that 27 minus X plus 20 minus X plus 22 is equal to 60. So what we do know then is 27 plus 20 is 47, and 47 plus 22 is 69. So 69 is equal to 69 minus X is equal to 60, and so X equal 9. So that means 9 students do both. 9 students do both math and bio. So 9 students do both math and bio. Since 9 students do both math and bio, it asks now, what's the probability that a student is doing both math and bio? So now that we find how many do, bio, and that means the probability of a student doing math and biology, probability of M intersect B is equal to the total number of students that do both, which is 9, divided by the total number of students in the school, which is 60. So that's part I. Now the second part says, what is the probability a student does biology only? So the probability a student does biology only. Let's work that out. So the probability a student is doing biology only, which is just the probability of B only, meaning biology only. That's going to be, how many students are bio only? 20 minus 9 is 11. That's going to be equal to 11 over 60. That's the probability a student do bio only. Nice and easy, soft. Now it says copy and complete the sample space. That's the next part of the question. We're just going to make a border around here. For part B, we're going to make a border around here. This is where we're going to do part B. And let's create the box now to represent the sample space. Nice and easy. So creating our box. In the meantime, we read the question. It is saying, two ordinary six-sided dice are thrown together. The random variable S represents the sum of their scores. Copy and complete the sample space. So this box that we're constructing is just a sample space diagram that represents the sum of the scores of the two dice. All right, so 1, 2, 3, 4, 5, 6, and we need 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. This is it. 1, 2, 3, 4, 5, 6. Yeah, this is good. Then we need 6 going down. 1, 2, 3, 4, 5, 6. All right, and just one final thing is missing. These are the dice going here. Oh gosh. Really trying my best to get these correct. Let me use a straight edge. Not doing so wonderful with this. Getting the straight edge. To get in the straight edge, we have 6, 5, 4, 3, 2, and 1. And this now is 1, 2, 3, 4, 5, and 6. Nice and easy. Now it wants us to fill out the sample space. So let's go ahead and fill out the sample space. The sample space is going to be right here, 1 plus 1. 1 plus 1 is 2. Then over here, it's going to be 2 plus 1, which is 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6, then 6 plus 1, 7. So that's the sample space. Let's go to here now. It's going to be 2 plus 1, 3, 3 plus 1, 3, 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, 2 plus 4, 6, 2 plus 5, 7, 2 plus 6, 2 plus 6, 8. That's the sample space right there. Let's go over to here now. 3 plus 1, 4, 3 plus 2, 5, 3 plus 3, 6, 3 plus 4, 7, 3 plus 5, 8, 3 plus 6 is 9. So get the gist of it already. So right here now, which is just going to be 4 plus 1, 5, 5, 4 plus 2, 6, 4 plus 3, 7, 4 plus 4, 8, 4 plus 5, 9. Then here it's going to be 4 plus 6, which is 10. Nice and easy. Right here, so now is 5 plus 1, 6, 5 plus 2, 7, 5 plus 3, 8, 5 plus 4, 9, 5 plus 5, 10, 5 plus 6, 11. Then up here now it's going to be 6 plus 1, 7, 6 plus 2, 8, 6 plus 3, 9, 6 plus 4, 10, 6 plus 5, 11, 6 plus 6, which is 12. Nice. So that's completed it. Then now part 2 says, let's try and we should be able to do everything right here. Break this all the way down here. Now part 2 is asking for find the probability that s is greater than 9. So let's work that out. It's saying find the probability that the score is greater than 9. So what's that going to be? So first, we need to identify scores that are greater than 9. It's going to be 1. All of these are greater than 9. Shouldn't put the line right there. Greater than 9 will be all of these. 10, 10, 10, 11, 12, 11. So greater than 9 is 1, 2, 3, 4, 5, 6. These are greater than 9. Greater means bigger than 9. These are all of them. So it's 1, 2, 3, 4, 5, 6. That's equal to 6 out of 36. 6 out of 36 is 1 over 6. I want the probability that s is less than or equal to 4. Find the probability that the score is less than or equal to 4. The probability s is less than or equal to 4 will be equal to all of these down here. 4 is all of these. 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are all of them, you know. 1, 2, 3, 4, 5, 6, 7. 4 here. 3, that's 7. 8, 9. That's equal to 9 out of 36. And 9 out of 36 is a quarter. That's the probability that the score will be less than or equal to 4. Now part 3. Boy, they're killing us with the table this time, man. Part 3 says, let D be the difference between the scores. And it says, let D be the difference between the scores of the faces landing uppermost. The table below gives the probability of each value. Find let D be the difference between the scores of the faces landing uppermost. Okay, so the dice, so you have two dice in it. You want the difference between the scores. Now it says, let D be the difference between the scores. Now complete the table. Now, if you chose 6, the difference will be, if you chose 6, if you chose 6, then the difference will be 0, clearly. If you chose 2, 6. In order for the difference to be 1, that means you chose a 5 and a 1. So this easy, man, this easy. All right, so let's go ahead and knock this question out. So first, I just want to complete that table. They seem to be killing us with tables this time around. And so we have D, and then we have the probability of D. Now when the difference is 0, the only way the difference can be 0 is if you throw like 1 and 1, or you throw 2 and 2, or you throw 3 and 3, you throw 4 and 4, you throw 5 and 5. That can only happen 1 out of 6, clearly. But I need nothing more. The next one now is for the difference to be 1. For the difference to be 1, that means you can show 1 and 2, or you can show, let me write it better. Let me show you what you can throw. The possibilities are you can throw 1 and 2, or you can throw 2 and 1, or you can throw 3 and 1, not 3 and 1, 3 and 2, or you can throw 2 and 3. Those still have a difference of 1. Or you can throw 3 and 4, or you can throw 4 and 3, or you can throw 5 and 4, or you can throw 4 and 5, or you can throw 5 and 6, or you can throw 6 and 5. Nice and easy. All right, so look how many options that were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So the probability, that means A is equal to 10 out of 36. You can simplify it if you want. So that is A. So A is equal to 10 out of 36. Some persons might want to simplify it and say A is actually divided by 2, that's 5 over 18. If you feel the need to simplify, go ahead and knock yourself out. Then for the difference to be 2, that is 2 over 9. For the difference to be 3 is B. For the difference to be 3 is B. Now what can you throw for the difference to be B? Now what you're going to be throwing for the difference to be 3 is if you throw a 1, then the next one needs to be a 4, or you can throw a 4 and a 1, or you can throw, say you throw 2, then the next one has to be a 5, or you can throw a 5 and a 2. If you throw a 3, then the next one has to be a 6, or you can throw a 6 and a 3. And so this is 1, 2, 3, 4, 5, 6 possibilities. And so what we're saying then is B equal, this is going to be 6 over 36. Now, of course, some people won't like to write it like that. Some people will want to write that B is equal to 6 over 36. And 6 over 36, we will want to say that is 1 over 6. Nice. Now, chances of the differences being 4 is going to be 1 over 9. And then the chances of the differences being 5 is, the only way the difference can be 5 is if you throw like 1 and 6 or 6 and 1. That's the only way. You have to throw 1 and 6 or 6 and 1. 1 and 6 and 6 and 1, that's 2 out of 36. C is equal to 2 out of 36. 2 out of 36, which we know is 1 over 80. Now it says now, the aptitude scores obtained by 51 applicants for a supervisory job are summarized in the following stem and leaf. It says find the median and the quartiles for the data given. It's 51 applicants. So since it's 51 applicants, the median occurs in the 26th position. So this is for part C. The median occurs at 26th position. So that's how we're going to find the median. We're going to look for the 26th score. All right, so let's look for the 26th score. Looking in the table, the 26th score is going to be 26 score, that looks like 71. All right, that's 71. So the 21 in the that's gonna be 71. It's equal to 71. So the person that got 71 on the aptitude test, that's the median. Next they want is the quartile. So let's find the lower quartile first. The lower quartile is going to be equal to, it's a quarter, it's 0.25 times n plus 1, which is 51 plus 1, which is 13. So we're looking for the 13th term, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The 13th term is 56. So the lower quartile is at the 13th position, and that is equal to 56. That's the lower quartile. Next we need is the upper quartile. So the upper quartile occurs at, clearly the upper quartile will be at the 39th position. And the 39th position is going to be, let's see, 3, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So the 39, that's 79. That's the upper quartile. Nice and easy. That's part C. Now it says construct a box plot to illustrate the data given. There's 5 information that you need. You need the minimum, the maximum, the median, and stuff like that. So let's construct our box plot. So this is the box plot. You draw a line. You draw a line. The lowest score, of course, is 31. So this right here is the minimum, which is 31. The maximum, which is the highest, is 96. And then the box plot, this is our Q1 and this is our Q3, Q1. The lower quartile is 56. And this is 79. Now the median is closer to this 71. So the median Q2 is somewhere right here, which is 71. This is the median Q2. This is the upper quartile known as Q3. This is the lower quartile Q1. Nice and easy, soft. Now we finally make it to the final question now. The final question is question number 8. Question number 8 says, figure 2 below, not drawn to scale, shows the motion of a car with velocity v as it moves along a straight road from point A to point B. The time taken t to travel from point A to point B is 90 seconds and the distance from point A to point B is 1,410 meters. So it tells us that the motion of the car is traveling along a straight road from A to B. The time it takes from A to B is 90 seconds. And the distance from A to B is 1,410. It says what distance did the car travel from A to B before it started to decelerate? So first thing it wants the distance that it was traveling. Remember distance of a velocity time graph, distance is equal to area under the graph. Area under the graph, that's how we find distance. And so the distance, so this is part 1, of course. Let's just label it, that's part 1, of course. The distance is equal to, let's call the distance S. The distance is equal to length times width, because that's a rectangle. The length looks like 30 seconds, and that's multiplied by the width of 25 meters per second. 25 meters per second. So when you multiply those, you get 30 times 25, 30 times 25. And so the distance before it decelerate was 750 meters. That's part 1. Part 2 says calculate the deceleration of the car as it goes from 25 to 10. Calculate the deceleration of the car. Now, deceleration is negative acceleration. So now the deceleration, which is negative acceleration, all right, so minus A, all right, or we can even write A just to say acceleration. Acceleration is equal to V minus U over T. That's acceleration, V minus U over T. The velocity is 25. Well, the initial velocity is actually 25. So it's a V velocity, which is 10 minus 25 over the time t, and the time t is 10 seconds. So what does that work out to be? This works out to be 10 minus 25 divided by 10, which is minus 1.5. And so this is the negative acceleration. This is minus 1.5 meter per second squared. And so the statement now is that we can say, so the deceleration is 1.5 meter per second squared. 1.5 ms to the minus 2. So the deceleration is 1.5 ms to the minus 2. Nice. That's a whole of 5 marks. It says for how long did the car maintain a speed of 10 meters per second? Oh shoot, an error was made right there. According to the graph, that's not 40, that's actually 38. This is 38, so this should be 8 seconds. My sincere apologies, it should be 8 seconds. Looking at the graph, that is 8. That is 8. Our mistake. That's not 10. It don't reach 40 yet. That is 8. So it's going to be 10 minus 25 divided by 8. That's negative 1.85. Negative 1.875. All right, so this should be the deceleration. Scrap this. Is 1.875 meters per second. They're trying to be tricky. But that's not that tricky. Then they said now, for how long did the car maintain 10 meters per second? It maintained it from 38 straight up to 90 seconds. So this is part 3. Part 3 is that we're just going to work out 90 minus 38. 90 minus 38 is 52 seconds. All right, and so the car maintained a constant velocity for 52 seconds. So the car started to go extremely slow because Usain Bolt can run at 10 meters per second in a 200 meters. So the car slowed down drastically. It says from point B, the car decelerates uniformly, coming to rest at point C and covering a further distance of 30 meters. Determine the average velocity of the car over the journey from point A to point C. So the car, it decelerates uniformly to cover another 30 meters. So if you cover another 30 meters, remember, so first and foremost, we know that the acceleration is going to be v minus u. V in this case is going to be 0. But we don't know the time, so that's a good one. This is a very good one. It just tells us that it covers 30 more meters. So what is that telling us? So it's telling us that the car is right here, and then it's going to come to rest. All right, it's going to come to rest. So it's going to form a triangle where this point, it's at point B. This is point B, and this is point C. All right, that's point B. And point B is when the time is 90 seconds. This is point C. We don't know how long that is, but from here, we know the velocity is 10. All right, and here, the velocity is 0. So now what do we know about this right here? We know that the area under the graph is 30. If the area under the graph is 30, but we know area of a triangle is a half the base, and the base is half the base, which is 90 minus, let's call this t, half the base, so So the base is t minus 90. Or let's just call it t for now. Let's just call that distance t. So it's half base times a height of 10. All right. So what does that tell us? A half of 10 is 5. So 5t, and so t equals 6. So if t equals 6, that means it takes 96 seconds in total. It takes 96 seconds in total to complete the full journey. And so now we can go ahead and find the average speed. So the average velocity is equal to total distance. Let me draw some more space. Average speed is total distance divided by total time. That's the average speed. Total distance divided by total time. And the total distance is add the 30 to the 1410. And so the total distance is just equal to 1440 divided by the total time to cover this, which is 96 seconds. And so that is equal to the average speed. 1440 divided by 96, that's 15. So the average speed is 15 meters per second. So go ahead, write it down. Tell them the average speed was 15 meters per second. That was the average speed. Nice. Finally, we're at the last portion of the paper, and it says a particle P travels along a straight line. It starts from rest at P, and after 10 seconds, it comes to another point Q, and the velocity V at the time after leaving P is given as follows. It says at maximum velocity, the particle has no acceleration. It says find the time when the velocity is at its maximum. So it says it has no acceleration. So at maximum velocity, the particle has no acceleration. All right? Maximum, the particle has no acceleration. So what that means is it has no acceleration when the particle has no acceleration when dv by dt is equal to 0, dv by dt. That's acceleration. So dv by dt is equal to, looking at the first one, it is 0. Carry down the power. So 2 times 0.72, which is 1.44. So I get 1.44 t. Then bring down the 3 now to get 3 times 0.096. That's 0.288. That becomes minus 0.288. That's acceleration. 1.44 t minus 0.288. And when this is equal to 0, it has, find the time when the velocity is at its maximum. Velocity is at its maximum when acceleration is 0. So from this, solving this equation, we're solving 1.44 t minus 0.288 equals 0. Solving this, we're getting 1.44t is equal to 0.288, and then we divide both sides by 1.44 to get t is equal to 0.288 divided by 1.44. That works out to be 0.288 divided by 1.44. That's equal to 0.2. All right, so we're getting t is 0.2. Just to check that no differentiation mistake was made. Oh shoot, differentiation mistake was made. Definitely made. This should have been carry down the power, subtract 1 from the power. Oh gosh. Subtract 1 from the power, and that's equal to 0. So now this is what we're solving. So we can factor out t. Factoring out t, we're solving 1.44 minus 1.44 minus 0.288t is equal to 0. So solving this, we're going to get two possibilities. We're going to get that t is equal to 0 or t is equal to solving 1.44. So t is either equal to that or t is equal to 1.44 divided by 0.288. And what is that working out to be? 1.44 divided by 0.288, that is 5. So it either t equals 0 or t equals 5. Now let's check out the other one as well. All right. Let's check out the other one as well. The other formula, the acceleration is going to be dv by dt for the next one, which should be 2.4 minus 0.48t. And if we're to solve this equals 0, what are we going to get for t? We're going to get that. Solving this, we're going to get t is equal to 2.4 divided by 0.48. That works out to be 5. So clearly t equals 5. So clearly, when t equals 5, the particle has no acceleration. Particle has no acceleration when t is equal to 5. And clearly it now have no acceleration at the start. Then it says determine the maximum velocity. Now, what I want you to know is whenever acceleration, so this is how the particle is traveling, right? So whenever it reaches its rest point, right, at this particular point, when it rests instant, when it just rests, right, it just when the acceleration is constant, the speed buck, this is at its maximum velocity when the speed buck. When the acceleration is 0, the speed buck, and this is the maximum velocity. So all we need to do is plug in t equals 5 to find the maximum velocity. So I'm going to call it V max. So the maximum velocity V max is going to be, we just need to plug in t being 5 in the formula, 0.72 times 5 squared minus 0.0 0.096 times 5 cubed. So let's need to work this out, and that gives us V max. So 0.72 times 5 squared minus 0.096 times 5 cubed, that is 6. So the maximum velocity is 6 meters per second. That's the maximum velocity. And you can check it in the other formula as well. You're going to get the same answer. 2.4 times 5 minus 0.24 times 5 squared. You're going to get 6. So the maximum velocity is 6. Then part C now. So this is part 1. This is the answer for part 1, which is 5. This is part 2. And we're at the final part of the paper now. Finish strong. You're running at 800 meters and you need to finish strong. You need to kick. Right? So 3. Find the distance moved by the particle from P to the point where the particle attains its maximum velocity. So remember, the particle starts from the point P, right? And so what are they asking? They said find the distance at the particle from P where the particle attains its maximum velocity. So the particle P is when it is at rest. That distance, you can call it S. It's going to be equal to the integral from 0 to 5, because it attains its maximum velocity when t is 5. So it's integral from 0 to 5 of 0.72 t squared minus 0.096 t cubed. This will give us the distance moved. This is all, this is all. So let's integrate this formula now. So integrate it to get add 1 to the power, divide by the power. So it's going to be 0.72 divided by 3 is 0.24 t cubed minus add 1 to the power, divide by the power. Now 0.096 divided by 4 is 0.0024. You'll get 0.024 t to the 4 over 4. Oh, we divided it by 4 already, so it's 0.024 t to the 4, and we're integrating from 0 to 5. Now we don't even need the 0. We're just going to plug in the 5. So plugging in the 5, we're going to get 0.24 times 5 cubed minus 0.024 times 5 to the 4th power. That will give us the distance it covered. So the distance it covered when we work that out is 0.24 times 5 cube minus 0.24 times 5 cube minus 0.024 times 5 raised to the 4th power, and I get 15 meters. So it covered 15 meters. So it covered 15 meters. Nice and easy. So it covered 15 meters up to where it obtained its maximum velocity. So that's it for now. So don't forget to just please subscribe to the channel, help the channel grow. It's only going to get better, the quality and everything. All the best prepping for your exam, and Work hard and you'll get those ones and those lovely distinctions. Now you take care.